Hello my friend, and welcome. I'm really glad you're here with me today. Wherever you're watching from, your bedroom, your car, your office, or maybe late at night with headphones on, I want you to know this video was made for you. Not to overwhelm you. Not to confuse you. But to gently, calmly, and honestly walk you through the way physics actually works in the real world. Now let me start with something that might sound a little uncomfortable. What if I told you that something Isaac Newton explained in school was misunderstood? What if I told you that physics works very differently from the way most of us were taught? I'm not saying Newton was wrong. Far from it. Newton was one of the greatest minds in human history. But what we were taught, the simplified classroom versions, the memorized formulas without meaning, the idea that physics is just equations on a board, that version of physics is incomplete. And in some cases, it gives us a completely wrong intuition about reality. Today, we're going to build something better. We're going to use Newton's ideas as a foundation, just like modern physics still does, but we're going to explain them in a clear, intuitive, modern way. No conspiracy theories. No fake science. Only ideas that are grounded in real, proven physics. But explained like a human being explaining reality to another human being. Before we go any further, I want to ask you something directly. If you find this video interesting or helpful at any point, please tap the like button. And I really want you to share your thoughts in the comments, even if you disagree with me, even if you're confused, even if something suddenly clicks in your mind. Interaction isn't just good for the algorithm. It's good for learning. When you think, respond, and reflect, your brain builds deeper understanding. When I was in school, physics felt like a strange mixture of magic and torture. Magic, because the teacher would say things like, everything falls at the same rate, or force equals mass times acceleration, and somehow these short sentences were supposed to explain the entire universe. Torture, because none of it felt connected to my real life. I memorized formulas. I passed tests. I forgot most of it, and for years, I carried a quiet belief that physics was something only geniuses truly understood, something distant from everyday reality. But one day, something changed. I was walking home in the rain, watching water drip from a roof. The drops fell. Some splashed. Some bounced. Some merged into streams. And suddenly, I realized something uncomfortable and beautiful at the same time. Physics is not happening in textbooks. Physics is happening right here, right now, all the time. The problem wasn't physics. The problem was how we were taught to think about it. So today, I want to start from the beginning. Not from equations. Not from complicated diagrams. But from reality. Let's talk about motion. Newton's first great insight, what we now call the first law of motion, says something incredibly simple. An object will keep doing what it's doing unless something forces it to change. If it's at rest, it stays at rest. If it's moving, it keeps moving in a straight line at constant speed. At first, that sounds obvious. Almost boring, but it's actually one of the most radical ideas ever discovered, because your intuition, and my intuition, tells us the opposite. You roll a ball across the floor. It slows down. It stops. So your brain says, motion naturally dies out. But that's wrong. The ball doesn't stop because motion wants to stop. The ball stops because the floor and the air are stealing its motion. Friction and air resistance are constantly draining energy from moving objects. If you could magically remove all friction and all air resistance, that ball would roll forever, not slow down, not get tired, not run out of motion forever. This isn't science fiction. This is real physics. And it has been tested in experiments again and again, and this is the first crack in the illusion of how we think the world works. Motion is not something that needs to be maintained. Motion is something that only needs to be changed. Stillness and motion are not opposites, they are equals. An object at rest is just as unnatural as an object moving at constant speed. The universe doesn't prefer stillness. It only responds to forces. Now let me slow this down and make it deeply intuitive. Imagine you're floating in deep space, far away from any stars or planets. There's no air. No gravity. No friction. No nothing. You gently push a wrench away from you. What happens? Your everyday brain says it moves for a bit, then stops. But physics says it will keep moving. Forever. In a straight line. At the same speed. That wrench will outlive civilizations. It will outlive mountains. It will outlive the earth itself. All because nothing is touching it. This is not just weird trivia. This changes how we understand reality. It means the natural state of the universe is not still. It's neutral. Things only change when something forces them to change. And now, we arrive at Newton's second great idea, force equals mass times acceleration. In school, this becomes F equals m times a, which students memorize and forget. But what does it actually mean? It means this: forces don't create motion, forces create changes in motion. Acceleration doesn't just mean speeding up. It means any change in velocity, speed or direction. Turning a corner in a car, that's acceleration. Slowing down to a stop, that's acceleration. Speeding up from a green light, that's acceleration. So Newton's second law is quietly saying something profound. The universe responds proportionally. A small force creates a small change. A big force creates a big change. And heavier things resist change more than lighter things. That's it. That's the core of it. No mystery. No magic, just a relationship between force, mass, and change. Now here's where our intuition starts lying to us again. We think heavy objects want to be still more than light ones, but that's not what's happening. Heavy objects resist changes more. That's called inertia. Inertia is not about laziness. It's about stability. Everything in the universe resists having its motion changed. A truck resists it a lot. A tennis ball resists it a little. That's all. There is no hidden desire inside objects to rest, are only resistance to change. Now let's talk about gravity, because this is where Newton becomes both brilliant and deeply misunderstood. Newton didn't say, things fall because they want to go down. He said, there is a force pulling everything toward everything else. The earth pulls on you, you pull on the earth. Yes, you are pulling the earth upward right now. The only reason the earth doesn't fly up into your feet is because it's unimaginably massive compared to you. Gravity is not a one-way force. It's a mutual attraction, and this attraction depends on two things: A, how massive the objects are, how far apart they are. The more massive they are, the stronger the pull, the closer they are, the stronger the pull. That's it. That simple idea explains why apples fall, why the moon orbits Earth, why planets orbit the sun, why galaxies hold together. Newton unified heaven and earth with one idea. The same force that makes an apple fall also controls the motion of the moon. That was revolutionary. Before Newton, people thought the heavens followed different rules. He showed that the universe is one system. But here's the part people get wrong. Newton did not explain why gravity exists. He described how it behaves, and that distinction matters more than most people realize. Physics is not always about explaining ultimate causes. It's about discovering consistent rules that match reality. Newton gave us rules that work unbelievably well. We still use them to design bridges, launch rockets, predict satellite orbits, calculate trajectories. Even today, even with Einstein's relativity, Newton is still everywhere. But here's the deeper insight that changes everything. Physics is not a collection of facts. It is a way of seeing. When you look at a falling cup, you're not just seeing a thing falling. You're seeing inertia being overcome by gravity, energy transforming from potential to kinetic, forces interacting across distance. The cup is not trying to fall. It's responding to the geometry and forces of the universe. Reality is not emotional. Reality is relational. Things happen because of interactions, not intentions, not purposes, not hidden desires inside objects. And this is where people start to feel something strange. A quiet existential feeling. If the universe is just forces and motion and interactions, where do we fit in? Are we just machines? Are our thoughts just physics? Are our choices just chemistry and electricity? These are real questions, and we're not going to avoid them, but we're not going to rush into them either, because before we talk about consciousness, we need to deeply understand the stage on which everything happens. Space, time, motion, force, energy. These are not abstract words, they are the grammar of reality. And Newton gave us the first clear grammar book of the universe, but like all first drafts, it wasn't complete. It wasn't wrong, but it wasn't the whole story. In the next chapter, we're going to go deeper. We're going to talk about why falling objects don't actually fall the way you think they do, what energy really is, why motion is secretly a story about perspective, and how Newton's universe quietly led us to Einstein. But before we go there, I want to pause, take a breath, and ask you directly, did anything in this chapter challenge the way you used to think about motion or gravity? If you're still with me, thank you. That already tells me something about you. It tells me you're not just here for entertainment, you're here because somewhere inside you, there's a quiet curiosity about how reality actually works. And that curiosity is the same force that drove Newton, Galileo, Einstein, and every great physicist who ever lived. Now let me start this chapter with a strange sentence: nothing is really falling. I know that sounds absurd. You drop a phone, it falls. You trip, you fall. Rain falls from the sky, but in physics, the word fall is a mental shortcut. A story our brains tell to simplify something deeper. Let me explain. When you drop an object, what you're really seeing is this: the earth and the object are accelerating toward each other. Yes, toward each other. The earth is pulling the object down, the object is pulling the earth up, both are accelerating. The only reason you don't see the earth move is because it's unimaginably more massive than the object. So the object does most of the moving, but in principle, both are falling toward a shared center of mass. That alone should already bend your intuition a little. Now here's something even stranger from the object's point of view. It's not falling at all. Imagine you're inside a sealed elevator, and the cable snaps. The elevator and everything inside it start accelerating downward together. What do you feel? Weightless. You float. Your phone floats. Your coffee floats. Inside that falling elevator, gravity seems to disappear. But gravity didn't turn off. You're still being pulled by Earth. So what? changed perspective from your frame of reference. You and everything around you are accelerating at the same rate. So relative to you, nothing is moving, which means no force. This leads to one of the deepest insights in physics. Gravity is not experienced as a force in free fall. You only feel gravity when something stops you from falling. The floor. A chair or the ground. What you feel as weight is not gravity pulling you down. It's the ground pushing you up. That sentence alone breaks most people's mental model of reality. You are not being crushed downward by gravity, you are being pushed upward by the earth. You are in a constant state of prevented falling right now. As you sit or stand, your natural motion, according to physics, is to fall straight through the Earth's center. The only thing stopping that is the electromagnetic force in the atoms of the floor pushing against the atoms in your feet. So weight is resistance to falling, not falling itself. This idea that gravity disappears in free fall is what later inspired Einstein to completely reinterpret gravity as geometry. But we're not there yet. First, we need to talk about energy, because energy is one of the most abused words in all of science. In everyday life, energy means motivation, excitement, electricity, or power. But in physics, energy means something much more precise. Energy is the ability to cause change. That's it. No mysticism, no vibes, just the capacity to make something happen. There are many forms of energy, but the two most important for understanding everyday reality are kinetic energy, the energy of motion, potential energy, stored energy because of position. When you lift a book onto a shelf, you're giving it gravitational potential energy. You're not putting energy into gravity. You're changing the book's position in Earth's gravitational field. Now the book has the ability to fall, and when it falls, that potential energy transforms into kinetic energy. The energy doesn't disappear. It changes form. This is one of the most sacred rules in physics. Energy is conserved. It can move. It can transform. It can spread out, but it cannot be created from nothing. And it cannot be destroyed into nothing. Every single thing you have ever seen happen, every explosion, every heartbeat, every thought, every lightning bolt, every falling leaf, is just energy changing form. Now here's the part that quietly connects Newton's world to the modern one. Motion, gravity, and energy are not separate ideas. They are different languages describing the same reality. Newton talked about forces and motion. Later physicists talked about energy landscapes. Einstein talked about curved spacetime, different maps, same territory. Let me make this deeply intuitive. Imagine a skate park. The ramps and bowls form a landscape. A skateboarder moves around based on that shape. If you drop the skateboarder at the top of a ramp, what happens? They roll down. Why? Because that's the direction of lower potential energy. They convert height into speed. Now replace the skate park with Earth's gravitational field. Replace the skateboarder with a falling apple. Same idea. The apple is rolling downhill in an invisible energy landscape. So gravity is not just a pulling force. It's a slope in the structure of reality. Things move the way they do because they are following the easiest path through that structure. And now we come to one of the most dangerous misunderstandings in all of physics education. Speed is not absolute. Motion is not absolute. There is no universal stillness. There is no universal movement. Everything moves only relative to something else. Right now, you feel still, but you are not still. You are rotating with the Earth at about 1,000 miles per hour. You are orbiting the Sun at about 67,000 miles per hour. The Sun is orbiting the center of the galaxy at about 500,000 miles per hour. The galaxy is moving relative to other galaxies. So, how fast are you really going? There is no single answer. Because motion is relative. Newton knew this, Galileo knew this, Einstein made it unavoidable. There is no cosmic speedometer, only relationships between observers. This means something profound. There is no privileged frame of reference. The universe doesn't come with a built-in camera angle. Every observer gets their own version of reality, and all of them are equally valid. This is not philosophy, this is experimental fact. It has been tested with clocks, airplanes, satellites, and particle accelerators. So when you say, the object is moving, what you really mean is the object is moving relative to me. And now, slowly, quietly, something radical starts to form. If motion is relative, if gravity disappears in free fall, if energy is just position and motion, then maybe the universe is not made of solid, fixed things doing fixed actions. Maybe it's made of relationships. Maybe reality is not a collection of objects, but a web of interactions. Newton gave us the first language to describe those interactions. And it was unbelievably powerful, but it left unanswered questions. Why is gravity exactly as strong as it is? Why does mass resist acceleration? Why does energy exist at all? Why does the universe obey mathematical rules? Newton didn't answer those questions, and that wasn't a failure. It was an invitation. In the next chapter, we're going to follow that invitation. We're going to talk about why time doesn't flow the same for everyone, why gravity is not really a force, how Einstein finished Newton's story, and why none of this makes the universe cold or meaningless. But before we go there, let me ask you something quietly. Has your sense of falling, weight, or motion changed since the start of this story? If yes, write it down in the comments, and if this is stretching your mind in a good way, please like the video. It truly helps thoughtful content survive in a noisy world. Up until now, we've been living in Newton's universe. A universe of forces, motion, mass, and energy. A universe that works beautifully for apples, cars, bridges, cannons, and planets. But Newton's universe had a hidden assumption. A silent belief that no one questioned for over 200 years. The assumption was this: space is absolute, time is absoluto, meaning there is one universal now. One universal clock ticking for the entire cosmos. One rigid, invisible grid of space that everything moves through. Newton didn't prove this. He just needed it to make his equations work, and for everyday life, it works so well that you never notice anything wrong. But then something strange happened. A light refused to behave. Physicists discovered that no matter how fast you move, the light always moves at the same speed and not relative to you. The same speed for everyone. This broke reality, because in Newton's world, speeds add. If I run forward at 10 km per hour and throw a ball forward at 20 km/h, you should see the ball moving at 30 km/h. That's common sense, but light doesn't do that. If I chase a beam of light at 99% the speed of light, I still see the light moving away from me at the speed of light, not slower, not faster, the same, which means something else has to give, and what gave was time. Einstein realized something terrifying and beautiful: time is not universal. It stretches, it shrinks, it depends on motion and gravity. 2 People moving relative to each other do not experience time at the same rate. This is not metaphor, this is not philosophy, this is measured reality. Atomic clocks flown on airplanes tick slower than clocks on the ground. Satellites have to correct for time dilation or GPS would fail. Your phone literally depends on Einstein being right. So time is not a background stage. Time is part of the physical world. It bends, it warps, it flows differently depending on where you are and how you move. And now comes the most shocking idea of all: gravity is not really a force. Let that sink in. Einstein realized something Newton never could have. When you fall freely, you don't feel gravity, which means gravity doesn't behave like a normal force. So what is it? Einstein's answer was radical. Mass and energy bend spacetime, and objects move along those bends, just like a marble rolling on a curved rubber sheet. The Earth bends spacetime. The moon follows the curve. You follow the curve. You are not being pulled downward by a mysterious force. You are following the straightest possible path through curved spacetime, and the ground gets in your way. That's why you feel weight. This means gravity is geometry, not a push and not a pull. A shape. And now Newton's universe transforms. Force becomes curvature, motion becomes navigation, falling becomes free motion, and suddenly, everything we said in the earlier chapters becomes even more true. The universe is not made of rigid things doing things to each other. It's made of relationships between energy, space, time, and motion. Reality is not mechanical. It's geometric. But here's the part people often miss: Einstein didn't destroy Newton. He completed him. Newton's laws are still true in everyday life. They are an approximation. A special case when speeds are low and gravity is weak. Newton's physics is what spacetime looks like when it's almost flat. So Newton wasn't wrong. He was incomplete, and that's not a failure. That's how science works. Each generation builds a deeper map. Now I want to pause here and talk to you like a human being, because at this point, many people feel something unsettling. If time bends, if gravity is geometry, if motion is relative, if reality depends on perspective, then what is real? Are we floating in some kind of illusion? Is anything solid? Is anything stable? And the answer is yes, reality is real. But it's not what your intuition thinks it is. You are solid, but your solidity comes from electromagnetic forces between atoms. You feel time, but your time is not the universe's time. You feel weight, but your weight is resistance to curved spacetime. Nothing becomes fake. It becomes deeper, more beautiful, more connected, and now, quietly, something profound happens. The universe stops looking like a machine and starts looking like a story. A story written in geometry, energy, and motion, and you are not outside that story. You are inside it. You are part of it. Your thoughts are physical processes. Your memories are patterns of energy. Your emotions are chemistry and electricity, but that does not make them meaningless. It makes them rare. It makes them miraculous, because in a universe of cold equations, somehow, atoms learn to think, stars learn to wonder about themselves. The universe became conscious of its own existence, and that happened through you, through me, or through every human being who ever lived. And suddenly physics is not just about falling apples. It's about identity. It's about existence. It's about meaning. But we're not done yet, because one final layer remains: energy, matter, and the quiet secret that they are the same thing. In the final chapter, we're going to talk about why mass is frozen energy, or why empty space is not empty, why the universe is not random chaos, and why physics does not erase meaning, it creates it. Before we go there, let me ask you something honestly. Did this chapter change how you think about time or gravity? If yes, tell me in the comments, and if you feel that quiet woe feeling in your chest right now, please like the video. That's how thoughtful ideas survive online. And I want to slow down here, because everything we've built so far, Newton's motion, Einstein's spacetime, energy, gravity, time, all of it quietly leads to one last, Profound realization. This chapter is not about equations. It's about what kind of universe you actually live in and what kind of being you actually are. Let me start with a sentence that once shocked the entire scientific world. Mass is just frozen energy. That's not poetry. That's physics. Einstein's most famous equation, E equals mc squared. Is probably the most misunderstood sentence in human history. Most people think it's just about nuclear bombs. It's not. It's about identity. It says this: energy and matter are the same thing, expressed differently. Mass is energy that's trapped in a stable pattern. Every atom in your body is a tiny knot of energy. Every rock, every star, every grain of sand, nothing solid is truly solid. Matter is energy that learned how to hold a shape, and now, something extraordinary happens. The universe becomes simpler, not more complicated. Simpler. Instead of matter, energy forces space-time. We now have one unified reality, energy moving through space-time, taking temporary forms, interacting with itself, becoming stars, becoming planets, becoming chemistry, becoming biology, becoming you. You are not a thing inside the universe, you are something the universe is doing right here, right now. Your body is a pattern in energy. Your thoughts are energy changing form. Your memories are stable arrangements of matter and electricity. You are not separate from physics, you are physics that became self-aware, and that realization alone quietly destroys a very old fear, the fear that physics makes life meaningless. It doesn't. It does the opposite. It makes life unimaginably rare. In a universe that could have been empty, it produced stars. In a universe of stars, it produced planets. On one planet, it produced life. From life, it produced consciousness. From consciousness, it produced curiosity. From curiosity, it produced physics itself. The universe is studying itself through your eyes. That is not cold, that is intimate. Now let's return to something that sounds technical, but isn't. Empty. Space is not empty. Classical physics imagined space as a dead stage. A black background where stuff happens. Modern physics says, even in perfect vacuum, energy still exists, fields still exist, particles appear and disappear. The vacuum is alive with activity. This means the universe is not made of objects floating in nothing. It's made of continuous fields, ripples, vibrations. Everything is connected through invisible structures. Nothing is truly isolated. Even when you are alone in a room, you are interacting with the Earth's gravitational field, the electromagnetic field, the cosmic microwave background, neutrinos passing through your body, quantum fields fluctuating inside your atoms. You are never separate from the universe, you are embedded in it. Dynamically, constantly. And now, finally, we return to Newton, because this entire story began with him. Newton gave us a universe of rules, predictable, orderly, and mechanical. Einstein gave us a universe of geometry, flexible, relative, dynamic. Modern physics gives us a universe of fields and probabilities, subtle, interconnected, alive with uncertainty, but all of them agree on something: the universe is lawful, not chaotic, not random nonsense. It follows patterns, deep ones, elegant ones. And the human mind is capable of understanding them. That fact alone is astonishing. Why should a brain made of atoms be able to understand the laws governing atoms? No one knows, but it's true, and that means something. Now I want to speak to you, not as a narrator, but as a human being. For a long time, I thought physics would make life feel small and meaningless, accidental, but it did the opposite. It made everything heavier with meaning, not religious meaning, not mystical meaning, existential meaning. You are a temporary structure of energy that can think, love, remember, and wonder. That is absurdly rare. You are a way the universe gets to experience itself. Your pain matters, your joy matters, your curiosity matters. It's not because the universe promised anything, but because in a universe with no obligations, you still exist. And now we come to the quiet conclusion of this entire journey. Newton was not wrong, school was not lying to you, but the truth was incomplete. Physics is not just equations. It's a way of seeing reality clearly. It's a way of replacing superstition with understanding, fear with insight, confusion with order. You don't live in a dead machine, you live in a living structure of energy and geometry. You are not an accident in the universe, you are a natural consequence of its deepest laws, and that makes you not smaller. It makes you part of something vast, intelligent, beautiful. Now let me end exactly the way I began. By speaking directly to you. If this story changed even one small way you see reality, then it was worth making. And if you felt that quiet shift in your mind, that subtle expansion, please tell me in the comments what moment hit you the hardest, and if you want more thoughtful, honest explorations like this, please like the video. It tells the algorithm that depth still matters. Thank you for staying with me through this entire journey, and remember this: you are not just in the universe, you are the universe, thinking about itself.